Okay, so what were we saying? Well, we were saying we added the 4 here because that was half of 4. 4 squared, half 4 is 2. 2 squared is 4. But what do I have to add to the other side? Well, notice that this 4 is actually multiplied by a 9. So when I put a 4 here, I actually added 36 to this side. So I have to add 36 to the other side. Same thing here. So half of 6 was 3. 3 squared is 9. Great. But this 9 was inside of these parentheses. The parentheses are multiplied by 4. So this 9 was actually multiplied by 4. So again, this was actually a 36. Now, I have 9 times x. This is a plus, half the middle term, squared, plus 4 times y. This is a minus, half the middle term, squared, equals negative 36 plus 36 plus 36 is 36. Okay, so at this point it kind of looks almost like a circle equation. So let's go back and look at the standard form. And this is what's going to be key for the ellipse. The same will be true for a hyperbola, spoiler alert, is that the equation is going to equal 1. So whether this is a horizontal or vertical major axis, I need the equation to equal 1. So how do I get this equation to equal 1? Well, the simplest thing to do is divide everything by 36. So when I divide this by 36, I will now have my standard form. X plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. That's my standard form. I can see that the larger number is underneath y, so this will be a vertical major axis. So let's label some things, or let's find some things. We know the center is the point negative 2, 3. I know a squared is 9, so a is 3. So my major vertices, since this was underneath the y values, this is going to get added and subtracted to the y value of the center. So my major vertices are going to be negative 2, 6, and negative 2, 0. B squared is 4, so B is 2, and since this was underneath the x values, this is going to get added and subtracted to the x value of the center. So my minor vertices are going to be negative 4, 3, and 0, 3. Last but not least, we can find that 9 minus 4 is 5, so I know C is the square root of 5. So my foci, again, it's going to get added and subtracted to the y value of the center, are going to be negative 2, 3 plus or minus the square root of 5. Boom. Alright. I want you to try this on your own. Identify the conic, write the conic in standard form, and find the key components of the conic. Pause the video, unpause when you're ready to check your work. Alright, so here the standard form should be x minus 1 quantity squared over 2 plus y plus 3 quantity squared over over 4 equals 1. The center then is the point 1, negative 3. Here, the larger number is under the y's, so that is my a squared, which is 4, so therefore a is 2. So the major vertices are going to be 1, which is the x value of the center, and then the y value of the center plus 2 and minus 2. So I'm going to get 1, negative 5, and 1, negative 1. The number under the x's is 2, so that is b squared. So b is the square root of 2. I know it's not a nice number. That's all right. The minor vertices are then going to be the x value of the center, 1 plus and minus the square root of 2, and then the y value of the center, which is negative 3. A squared, 4, minus b squared, 2, is 2, so c is also the square root of 2. So then the foci, the c value is going to be added and subtracted to the y value of the center, since this is a vertical major axis, since the larger number was under the y's. So 1, comma, negative 3, plus or minus root 2. How do we get that, though? So, if we go back up to the top, I know this is an ellipse because the a, or in the generic general second degree equation, the number or the coefficient in front of the x squared and the coefficient in front of the y squared have the same sign but different values. So then I grouped the x's, I grouped the y's, I brought the constant over to the other side. I factored out the leading coefficient from the x's, and then I completed the square. So I had x squared minus 2x, half of 2 is 1, 1 squared is 1. Since this 1 is multiplied by 6, I added 6 to the other side. I factored out the leading coefficient from the y's, so I factored out the 3. So then I was left with y squared plus 6y. Half of 6 is 3. 3 squared is 9. 9 times 3 is 27. Now I can complete the square. X, this was a minus, half of the middle term, quantity squared, plus 3 times y. This was a plus, half the middle term, quantity squared, equal 12. I need this to be a 1, so then I divided everything by 12. That's how I got my standard form. Alright, so we need to understand the ellipse, the standard form of an ellipse, how to get values from that, the A and the B, understanding what we mean by major and minor axes, and then most important, being able to change the general second degree equation into the standard form of an ellipse once we recognize it is an ellipse.